Alright, so this is my pendulum lab. I started off with a protractor, a nail in my wall, which was already there, some twine, a carabiner, and then on the rope I marked at 80, 100, 120, and 140 centimeters. I then attached the carabiner and would, you know, adjust accordingly depending on what measurement I was taking for what length. And then I would use the protractor and make sure that it was at 90 degrees. And then from there, I would pull out 10 or 20 degrees. And then I would let it go. And I would do that for 10 oscillations. And then repeat that 3 times. And then average out the time. And use that to calculate our gravity. Thank you.
Alright, so I'm here with my data and I just wanted to give you guys a quick little example. So, here is the 80 centimeter, that's our length. These were the times that we got for the 10 oscillations. This is the average. This is the average divided by 10. That's going to give us our period, right? One oscillation. So we have 18.22 divided by 10 oscillations, right? So that's going to give us, obviously we just moved the decimal place over 1, and that gives us our time per 1 oscillation, right? And that's important because that's our period. We have an equation, period is equal to 2 pi times the square root of L divided by G, right? So let's rearrange this so we can find gravity, right? So let's do T divided by 2 pi equals the square root of L divided by G. So we can actually break this part up into, just erase that. Okay, so now we're going to flip these two, and we're going to get square root of G is equal to square root of L divided by T divided by 2 pi, right? So now we know this denominator right here is gonna flip up to the top. So we're gonna get the square root of G is equal to the square root of L times 2 pi divided by T. Now let's square both sides. We get G is equal to 4 pi squared times L divided by T squared. So now this, obviously we know our L. Our L is equal to 80 centimeters, which is equal to 0.8 meters, right? And we know that our T is equal to, what we just calculated it, 1.822 seconds, right? We're actually going to square this, so square that. We're going to plug those numbers into this. And when we do that, we come out with 9.52 meters per second squared. And obviously the units make sense because these are unitless, right? Our 4 pi squared is unitless, so our length is in meters, our t squared is seconds squared, right? So that's our units. All right, so that's the first part. Now the second part of the lab wants us to figure out the g, right, according to our slope times our constants, right? So we can figure that out by using, once again, the same equation. Let's just start off from where we left, right, at this part. So we're going to say that we have g is equal to 4 pi squared, and with a little bit of just, multiplicative property, we can just say L over T squared. And this L over T squared, like we have here, right, our length over here, and our period right here. So that's our slope. So G is equal to 4 pi squared times our slope. So in this case, let's just use the bottom one, for example. g would equal 4 pi squared times 0.241. I believe that comes out to something like 9.5 meters per second squared. So yeah, that's how we completed the lab and did all the calculations. Thank you very much.